Sketch a graph of x is greater than 3 and express the solution in interval notation. First, I'm going to draw a number line so that we can look and see where the solutions fall. Now, if we look at the inequality, x is greater than 3, we're looking for numbers x that are greater than 3, so numbers that are larger than 3. So when I ask students what is a solution to this inequality, x is greater than 3, usually the responses that I get from students are 4, 5, 6, and 7. But there are other numbers that are larger than 3. For example, 4.5 is larger than 3, 5.5, 6.5. We could also look at 3.1. We could look at 4 3/4. It's 3/4 of the way between 4 and 5. In fact, we could go on and on forever because there are infinitely many solutions. There are infinitely many numbers that are greater than 3. And so instead of taking an infinite amount of time and plotting each of these points individually, because that would take forever, what we do when we're graphing inequalities is we shade in the part of the number line where the solutions fall. Now, because our inequality is x is greater than 3, we want to shade in the part of the number line where the numbers are greater than 3, and that would be all of the numbers to the right of 3. So we shade in everything to the right of 3. And because they never stop, even if we keep going to the right further and further, those are greater than 3, we're going to shade in the arrowhead at the end of the number line to say that the solutions keep on going. Now, the last thing we have to be careful about here is what's happening at 3. If we substituted 3 into the inequality and had 3 is greater than 3, that would not be true. 3 is not greater than itself, it's equal to itself. That means that 3 is not a solution to this inequality. And the way that we represent that on the graph is by putting an open circle around the 3. That's basically saying that the end point is 3, but because it's an open circle, 3 itself isn't actually a solution. Now, there's one more thing we have to do here. We were asked to express the solution in interval notation. So there's a particular notation that we have when we want to talk about all of the numbers in a given interval. And the way that we express this is by listing what the endpoints of the interval are. So if you look at the part that we've shaded in, and if I were to ask you, where do we stop shading as we move to the left, we would stop at the number 3, right? We keep going, and then we stop right at 3. So that means when we write this in interval notation, 3 is our left endpoint. Now on the right, we keep going and going and we never stop. So technically we head towards infinity. So the right-hand side of our interval notation is going to be infinity. So we've got 3 comma infinity. Now we need a little bit more because we have to distinguish between whether 3 is a solution or 3 is not a solution. When an endpoint is not a solution, which corresponds to an open circle, we use a parenthesis to denote that. So this means that we shade all the way up to 3 on the left, but we don't actually include 3. And whenever we have an infinity in interval notation, the convention is to put a parenthesis there as well, because technically infinity is not a number. It doesn't exist anywhere in the number line, it's just an idea. And because it's not actually a number, it's not actually a solution, and so we use parentheses there. So in general, the rule is whenever there's an infinity, you're automatically going to use a parenthesis. And then if there's an open circle, meaning the number is not included, you also have a parenthesis. When that number is a solution, we'll see in the next example how to deal with that. But for right now, we have parenthesis, 3 comma infinity parenthesis.